AP Calculus BC-6 2000. So in this problem, you're supposed to consider the differential equation given by dy dx equals x times y minus 1 squared. And A says, on the axes provided, sketch a slope field for the given differential equation at 11 points indicated. So then it gave you the points that you got to indicate, and then you just plug in the coordinates into the equation, and then you get the slope, and you just draw the slope like that. B, use the slope field for given differential equation and explain why the solution could not have the graph shown below. And then it shows a parabola, just a regular parabola. And B, the answer is the graph does not have a slope of 0 where y equals 1. See, slope of 0 right here is where y equals 1. Slope of 0, slope of like 1. And part C, find the particular solution to y equals f of x to the given differential equation with the initial condition f of 0 equals negative 1. And what you got to do is you got to put y over y minus 1 squared times dy equals x dx. Then that goes to negative 1 over y minus 1 equals 1/2 x squared plus c, because you've got to take the integral of that. And then you go 1/2 equals 0 plus c, and c equals 1/2. Then you plug it in, and you get negative 1 over y minus 1 equals 1/2 times x plus 2 plus 1. I mean x squared plus 1. Shit. Is it still recording? Yes, it is still recording. And then you get that equals y equals 1 minus 2 over x squared plus 1. And for part D, it says to find the range of the solution found in part C. And the range is between negative 1 and 1. And that is the summation of 2, and you get 1 colon 0 slope at 7 point with y equal 1 and x equals 0. And 1 colon negative slope at negative 1 comma 0 and negative 1 comma negative 1. And a positive slope at 1 comma 0 and 1 comma negative 1. And then a even steeper slope at y equals 1 than y equals 0. So that is the range of the solution. 1989 BC Calculus number 4. Consider the differential equations given by dy dx equals xy over 2. So for part A, it says on the axes below, sketch the slope field. And again, just plug in the points into the equation, and it'll give you the slope for that point, and then you just draw the slope. B, let y equal f of x be the particular solution to the given differential equation with the initial condition of f of 0 equals 3. Use Euler's method starting at x equals 3 with a step of 0.1 to approximate. To approximate f of 0.2, show your work. And below, you get f of 0.1 is approximately equal to f of 0 plus f prime of 0 times f of 0.1. And you get 3 plus 1 over n times 0 times 3 times 0.1 equals 3. And then you get f of 0.2 is approximately equal to 0.1 plus f prime of 0.1 times 0.1. And you get 3 plus 0.03 over 2 equals 3.105. Alright, and lastly for part C. Find the particular solution y equals f of x to the given differential equation with the initial condition f of 0 equals 3. Use your solution to find f of 0.2. And in this one, dy over dx equals xy over 2. That was the original equation given. And you have to take the integral of dy over y, and that equals the integral of pi over 2 dx. And you get the ln of y equals 1/4 x squared plus c. And then you get y equals c e to the x squared over 4. And then that also goes to 3 equals c e to the 0. Then it goes to c equals 3. And then y equals 3 e to the x squared divided by 4. And you end up with f.2 equals 3e to the 0.4 divided by 4, which equals 3e to 0.1, which equals 3.030.